Hello, welcome to our last FRQ of the day before our exam. Of course, if you want, I can continue making them. If one of y'all's like taking the late exam, I'd be glad to do that because I don't have anything better to do, but not really. And I kind of enjoy doing these things. But anyway, yeah, so for this one, we're going to do the 2006 number 4, which I think is very much the sort of thing you could see on this year's exam. But anyway, so let's see if we can figure this one out. So this one says patients with heart attack symptoms arrive at an emergency room either by ambulance or self-transportation provided by themselves, family, or friends. When a patient arrives at the emergency room, the time of arrival is recorded. The time when the patient's diagnostic treatment begins is also recorded. An administrator of a large hospital wanted to determine whether the mean wait time, the time between arrival and diagnostic treatment for patients with heart attack symptoms, differs according to the mode of transportation. A random sample of 150 patients with heart attack symptoms who had reported to the emergency room was selected. For each patient, the mode of transportation and wait time were recorded. Summary statistics for each mode of transportation are shown below. So if they arrived by ambulance, there were 77 of them. There's their mean wait time, and there's the standard deviation of their wait times. And if they drove themselves or just not an ambulance, there were 73 of those. And the mean wait time was that, and the standard deviation of the wait times was that. Part A, use a 99% confidence interval to estimate the difference between the mean wait times for ambulance-transported patients and self-transported patients at this emergency room. And then Part B, based only on this confidence interval, do you think the difference in the mean wait times is statistically significant? Justify your answer. So if you want to pause this video and give that a shot, that would be great. Alrighty then. Now, so it says create a confidence interval. So guess what? We got to do the TAME acronym. Anytime you create an interval, TAME acronym, we got to state the type of inference, we got to state the assumptions, we got to do the mechanics, and we got to state the ending. We got to do those 4 things. All right. And so the first thing is the type of inference. This is a 2-sample T interval for means. Remember, this is means, and who's mean? And that would be Mr. T. And we have 2 samples. So it is a 2-sample, and we're doing an interval, so it's 2-sample T interval for the difference in means, and that is the name of it. Then we have to send. We got to do our assumptions. It says the 150 patients were randomly selected, so independent random conditions met. Remember, with 2 samples, you have to say independent random condition is met. Okay, in other words, that the samples weren't influencing each other in any way, nor did you have any sort of pairing going on. Okay, here. And so, therefore, there were independent random samples. All right, our population sizes must be at least 10 times our sample sizes. That ensures our formula for standard error will work. So there has to be at least 750 ambulance-driven patients like these and 730 self-driven patients like these for our population sizes to be at least 10 times our sample sizes. Lastly, we have to have normality. And so normality with means, remember, there's 3 possibilities. Either your sample sizes are bigger than 30, or it could say that it varies approximately normally in the problem. Or you could graph the data, and as long as you have outliers or strong units, you're going to say normality is reasonable. But in this case, this is the easy option. Both the sample sizes are bigger than 30. So we'll say what the sample sizes are. They're both greater than 30. By the CLT, by the central limit theorem, normality is met. And that's all you have to say. So there's the assumptions. I would be really surprised if checking the assumptions is not at least one of the problems in the exam this year. You're going to send, so make sure you're cool with doing that. Anyway, and so then our mechanics. There's the formula, and there's the interval. Of course, you could use. Now, what's going to happen on this year's exam, I feel pretty confident, is that they're going to give you the interval and ask you to comment on it. But this is how you would find it with your calculator. And so you would hit the stat button. So you would go stat, and then you would go test, and you would say this is a 2-sample T interval. So you'd scroll down to option 0, 2-sample T interval. And so we're entering stats here. And so our first mean is 6.04. So you go 6.04. And then our first standard deviation is 4.3, and then our first sample size is 77, and our second mean is 8.3, and our second standard deviation is 5.16, and our second sample size is 73, like that. And then it's 99% confidence, so So 99% confidence. Always say no to pooled when your calculator asks you to do pooled. Then calculate, and there you go. And there is your confidence interval. And there's your degrees of freedom. Remember, with if it was one sample, the degrees of freedom would be the sample size minus 1. But with 2 samples, there's a complicated formula for it that's not a part of the AP Stats curriculum. You can just get it off your calculator, or it's going to be given to you. Or if you don't have a calculator, just use the smaller sample size minus 1. So you could use 72 in this case. So in other words, like answers on this could vary just a little bit, but it'd still be really close to that. So that's how you get the interval. And then of course the ending, and it'd be, look, the ending for a confidence interval and for a hypothesis test, it's definitely going to be on this exam. I feel very strongly. All right. And it's not just me, it's the gurus as well. And so how do you do your ending? How do you interpret the interval in context? And that's what the ending is. And you'd say, I'm 99% confident that this interval captures, and then you state what you're measuring, the parameter, which in this case is the difference of parameters, because there's 2 of them, captures the true population difference of the mean wait times for the ambulance-driven and the self-driven patients like these at this hospital. So there's kind of different ways you could word that, but just I'm 99% confident this interval captures the difference in the proportions, okay? That's interpreting the confidence interval. If it asks you to interpret the confidence level, in other words, what do they mean by 99%? You would say, if we did this procedure many, many times and made many, many different intervals, 99% of them would capture the true difference, or the true parameter, difference in parameters. There you go. All right, okay. So, but it didn't ask us that. Now, part B, it says, based only on this confidence interval, do you think there's a difference in the wait time? Or do you think the difference is statistically significant? Well, what do you think? Well, once again, 0 is not in the interval. 0 represents no difference. It's not in the interval, so it's not plausible. Okay, so we would say so to answer. Make sure you answer the question. By the way, do you think the difference is statistically significant? And we would say yes. 0 is not in the interval, so 0. Okay, 0 is not in the interval, so not 4. So it is not a plausible value for the true difference. At the 99% level, it's good to mention the confidence level there. So the p-value of the related test would be less than 0.01. So thus, there does appear to be a difference in the mean wait times. Okay, there obviously was in the samples. What this is saying is that the samples were so different, is that we are really confident that the population values are also going to be different. And so that's how you would word that. And that's it. That's how you do that. And if you have any questions about that, please let me know. And so anyway, really miss seeing y'all. Look forward to getting to see y'all again sometime. And hope you're doing well. And like I said, if you got anything you need to to chat with me about, then just send me a message.